Hey guys, this is day 2 of experimental research, and I think this will be a pretty easy lesson. Very important stuff here. We already discussed what is an experiment, and you need to know that stuff. That is extremely important. Today, we're going to take the experiment and we're going to talk about how the experiment is better, if you can do it, better than any other kind of research. But you can't always do an experiment, okay? There are many reasons why, but we're going to talk about the advantages and disadvantages of all kinds of research. Now, the advantage of an experiment is it establishes cause and effect. Okay, so if you want to know if A causes B, you do an experiment. However, every other kind of methodology doesn't establish a causal relationship. So that would be a disadvantage to every other kind of method. Okay, so let's talk about the other ways of finding out human behavior. First of all, descriptive research simply means that you are describing what you see. And there's many ways to do this. Okay, you could observe them and write it down. That's naturalistic observation, but we'll talk about that later. Okay, but that's descriptive research is basically anything that's not an experiment. So these are all and we're going to talk about all this stuff. These are non-experimental research. None of these are experiments. So none of these establish what causes something. Okay, and we're going to talk about these right now, not in this order. Okay, so let's talk about the case study. The case study, and the key word is in depth. If you want to study something that in depth, then you do a case study. Now let's use sociology as an example. Let's say you want to study school shootings. So you find one school shooting and you go and you interview the people for months. You talk about it, you look through the police records, and you may write an entire book on just the Columbine shooting. Okay? So the pro of a case study is that you can study something in depth. However, the bad part is that it may not generalize to the rest of the population. So maybe Columbine was different than other school shootings. Okay, here's another example. Case studies are really good if you find something extraordinary or interesting. So if you want to do a case study on short-term memory and long-term memory and stuff like that, you may go and do a whole study on Clive Waring. You'll interview his wife, and you look at his brain scans and you read his diaries, and then you may write a whole book on just Clive Waring. Now, is Clive's case, is that generalizable to the rest of us? I don't know, but that's the problem with a case study. The case study is good when you want to study something particularly interesting, particularly unique. Okay? Longitudinal studies. So remember the intelligence video we watched about how these Scottish kids took an IQ test at age 11 and then they took it again at age 80? Something like that. That would be an example of a longitudinal study. You measure the same people over a long time. Longitudinal studies, underline the word long in longitudinal. Longitudinal studies take a long time. You study the same people over a long time. And it's not just for developmental psychology. Yes, it's good for developmental psychology because you can study development over the same individuals. But what if you want to study personality? Does conscientiousness change over time? So you might give a 10-year-old the Big Five personality test, give it to him again at age 30, give it to him again at age 50, give it to him again at age 70, and see if their Big Five personality traits change over time. That would be an example of a longitudinal study. Okay? But again, remember the problem with longitudinal studies is that they take a long time. But the good thing about them is that you don't have to deal with variations in genetics and nature versus nurture. You're studying the same people over a long period of time. Cross-sectional studies are much easier to do. You just study different sections of people. Now, if it were developmental psychology, you might study second graders, fifth graders, high schoolers, middle-aged people. That would be a cross-sectional study. But what if you wanted to do intelligence and you wanted to measure the intelligence of older people, middle-aged people? But it's not just ages. It's also what if let's say you're a political scientist and you want to study politics and you want to find out what people's attitudes are toward healthcare. What are people's attitudes toward gun control? Are poor people's attitudes different than middle class people? Are people in the South, is their attitude different than people in the North? So when you get into political science and you get into polling, cross-sectional studies are very popular because they're easy to do. And they don't take that long to do. You just get a bunch of people, you call people, you get in contact with people, you get them to answer a survey, and then you could be done in a week or two. Okay. As longitudinal studies, however, last a long time, cross-sectional studies don't. Okay. So let's talk about the survey. Surveys are cheap. That's a good advantage of a survey. They're anonymous. They better be. Okay. And they're not that hard to do. They're easy to do as long as you have a random sample of the population that you're studying. Okay, so let's say you're doing a political survey. I like politics, so I always go political. Let's say you want to find out who's going to win the next election. Well, you don't want to just call landlines, okay? Meaning land phone lines, because only old people have landlines anymore, and you're going to miss out on the younger people. So then that will not be a random sample, okay? So why don't you just do cell phones? Everybody's got a cell phone. No, because then you'll miss the old people who don't have a cell phone. You might miss some poor people. So when you do a psychological survey, you have to do a random sample of the population that you're surveying. Okay? So remember, a census is when you ask everybody. A sample is when you take the census, everybody in the population, and then you pick their names out of a hat. Obviously not literally, but it's computers do it. They take everybody's, they give everybody a number and then they draw their number out of a hat, not literally, but with a computer to create a sample. If you want to do a survey of people at your high school, then you would take everybody in the high school and then randomly select people from that list of everybody in the high school. And then you get them to answer the survey. Okay? Now, the good thing about surveys is that they're cheap and they're easy to do and they're fast. Okay? But the problem is that people aren't always honest on surveys. Also, people don't always answer surveys. When you get a strange number on your cell phone calling, do you answer the phone? A lot of us don't. Okay, if I get a number that I don't recognize, I just won't answer the phone. It is getting more difficult to do surveys nowadays. Framing, you got to word that question just right. Otherwise, you might bias the answer. Okay, so if you ask people's opinions on abortion, if you phrase it in a way of saying, do you support the woman's right to privacy? That's going to give you a much different answer than, do you support the right of a woman to murder her unborn child? Again, those are two different sides of the debate, and you got to watch how you frame the question. Social desirability bias. People lie. If you ask, if you ask a bunch of ninth graders, "How gay are you?" People are going to lie. They may not even know. Okay, people may lie about that stuff. Infidelity. Have you ever cheated on your husband? Have you ever cheated on your wife? People lie about that stuff on surveys. So you got to understand that surveys are they're not perfect either. Okay, but sometimes they're the best that we have. So this is the survey method. This is the stuff that we just talked about. Hit pause if you're taking notes. Okay, and then there's naturalistic observation. Piaget did this. Piaget, he was the guy, he would go to playgrounds and watch kids play. And I know that sounds creepy, but yeah, look at the little girls, look at the little boys playing on the playground, and he would give kids puzzles, like the graham cracker and the beaker test. Piaget did that. That's naturalistic observation. And the beauty of this is that you can observe and record people in their natural environment. Naturalistic observation is when you watch people do what they do and you take notes. Okay, that's naturalistic observation. Kind of like Jane Goodall and the chimpanzees. She would go out into the jungles and she would watch the chimps, usually from a distance, and she would work for years, decades. She would just write down what she saw. It's kind of like you going to the cafeteria with a notepad and you take notes about observations that you see. Like what are the cheerleaders doing? What are the band people doing? And you write it down. That's naturalistic observation. The problem with this is observer bias. Okay. Let's say you don't like rednecks. So you see rednecks over here doing something and you write something negative about their behavior, but then you see some other kids that you do like and you write something positive about the same behavior. Okay, you get into racism, you get into stereotyping and things like that. And you get selection bias and confirmation bias and all kinds of biases when you're observing people in their natural habitat. That's a problem with naturalistic observation. And of course, another con is that when you observe something, that doesn't mean that you know what the cause of that behavior is. Okay, only an experiment can determine the cause, not naturalistic observation, not surveys. And then meta-analysis. Think about the word meta. You might have heard this meta. When I'm on Reddit, I hear about meta GIFs, and that's a GIF about GIFs, or a meta tweet. A meta tweet would be a tweet about Twitter in general. Meta, think about the big picture. So let's say you want to do a study on something. So what do? Instead of doing your own study, you get everybody else's study on that particular topic and you combine the results. Okay. So for example, I'll look this up. There was a meta study done of 22 experiments, because there have been a lot of experiments done on, do vaccines cause autism? And there have been so many experiments done on that topic. So what if you combined all of the experiments together, and then ideally it becomes more powerful? You bring them all together and it makes a much more powerful statement, bigger sample size and everything. A meta study of 22 experiments revealed that vaccines do not cause autism. Okay, so that's pretty much settled in the scientific community. All these experiments come to the same conclusion. And when you combine them, that's a meta study or a meta analysis. Okay, here's a good visual that I have students draw on their note card. Okay, you combine all of these studies into one meta analysis. All right, so A person displays a set of rare behaviors that psychologists had not known about previously because nobody had ever shown them before. The best strategy to investigate the nature of those behaviors is what? So imagine if you find two twins separated at birth. Those are not that common, and then you want to study them a lot. That would be called a case study. All right, I need to talk to you more about correlation studies in a minute, but the results of a correlational study involving student volunteers in a psychology laboratory might not apply to the general population. Because why? Okay, there is a problem in colleges where professors will say, you students, you need to come be a part of my psychology experiment. Okay, you can't do that. First of all, that's coercion. You can't make people be a part of your study and say you're going to fail my class if you don't do it. Second of all, you don't get a good representative sample of the population. College students are not always representative of the general population. Sometimes they are, sometimes they're not. So the answer is B. If you're in a and this would also be volunteers in a psychology laboratory. People who volunteer to come and be a part of your study, people who volunteer are not necessarily a random sample. Okay? People who come to you wanting to be a part of it are not necessarily like everybody else in the population. Okay? Drawing a random sample of people from a town for an interview study of social attitudes ensures that what? Okay, I don't love this question, but hit pause and try it out yourself. The answer is A. The answer is A. Basically, the answer is just a definition of what is a random sample. Okay? Students from a journalism class ask only their friends to participate in a school newspaper survey and neglect to ask the rest of the student body. The journalism students' data may not be generalizable due to what? And the answer would be sampling bias. You got to have a good random sample. If you only ask your friends, you're going to leave out the dorks that aren't your friends, or you're going to leave out the cool kids that aren't your friends. And you're going to leave out people that you don't like. Everybody needs to have the same chance of being a part of it, even if they don't get selected. Okay? Dr. Jones is interested in studying the relationship between weight loss and mood. To conduct the study, Dr. Jones analyzes the results of several previous studies on weight loss and emotional state. The answer is A. That's a meta-analysis. Okay. Research shows that women who are referred by a physician to participate in the study of eating disorders have more severe problems than women who volunteer on their own or to participate in the study. If research on eating disorders regularly involves only women referred by physicians, the results of the studies might be limited because of the presence of people need to be randomly chosen. You can't just have a selection problem only. The answer is A. That's called sampling bias. Okay, you got to have a good random sample. You can't have sampling bias. Okay? Which is considered a disadvantage of naturalistic observation. Remember, the disadvantage of anything other than an experiment is that it doesn't identify the cause of the behavior. Only an experiment does that. Okay? Now, let's talk about correlational research. I've mentioned this a lot, but understand that just because two things are correlated doesn't mean that one thing causes the other. Okay, so in July, ice cream rates go up, and the murder rate also goes up. So that makes it obvious. Killing people causes people to want to eat ice cream. Or maybe it's the other way around. Eating ice cream causes you to want to commit murder. Or maybe it's just a coincidence and they have nothing to do with each other. Or maybe the same thing causes both. You just don't know that. You'd have to do an experiment to find out what causes murder. And you can't do that experiment. Okay. By the way, heat causes both. And when it gets hot in the summer, people tend to hang out outside. And when people tend to hang out outside, they interact with each other and then they get drunk and sometimes they kill each other. So murder rates do go up in the summer. That's true. Okay. Correlation studies show that there is a strong correlation between how many books are present in a child's home and college completion rate. So you can imagine all the parents going out and buying a bunch of books, and it doesn't matter if the kids read them or not. That there have been studies done, and if there is books in the house, people are more likely to go to college. So, do the books actually cause kids to go to college? No. Oh, yeah, and that goes back to if your kid listens to classical music, then your kid's going to be smarter. Oh my God! I mean that was a big thing in the '80s. It was ridiculous and kind of racist too, really. Okay. Studies show that people who smoke marijuana have fewer health problems. Does that mean that marijuana cures you of health problems? I thought about this a lot, and I've talked to you about it a lot. Um, this is me. I came up with this. Younger people, for whatever reason, smoke more often than older people, and younger people tend to be healthier. It's the truth. Okay, but being healthy doesn't cause you to smoke, and smoking doesn't cause you to be healthy. In order to find that out, you would have to do an experiment. Okay, and that's they have done experiments in Europe, but not in the United States. So check this out. Low self-esteem and depression are correlated. Oh, and by the way, look at the word correlation. Co-relation. Co means together. Cohabitation, living together. Co means together. Cooperate. Okay? Correlation, relate together. Low self-esteem and depression are correlated. But does low self-esteem cause depression? Does depression cause low self-esteem? Or does something else cause both? Okay? All right. Now check this out. There's this wild conspiracy theory that 5G is causing the coronavirus. Because if you look at the map, and you get the 5G coverage map on top, and then you look at the coronavirus distribution on bottom, oh my God, it's obvious 5G is causing coronavirus. We all know that that's silly, okay? But just because two things are correlated doesn't mean that one thing causes the other, okay? But this is the kind of thinking that people do, okay? Now, what do these two things have in common? Probably high population density. It's because you're not going to put 5G out in the middle of nowhere, okay? And coronavirus is going to spread more easily in crowded areas, like New Orleans or New York City. All right, now there is a number called the correlation coefficient. Correlation coefficient. It is a number between -1 and +1. And it describes whether it's a positive relationship or a negative relationship. Okay? 0 means that there is no relationship. Now remember, just because there's no relationship Just because there's a relationship doesn't mean that one thing causes one another. Okay? 5G and coronavirus are related, but that doesn't mean that one causes the other. Murder and ice cream are related. Okay? So it is a number -1 or greater and +1 or less than. Okay? And 0 means that there is no relationship. So if you get a correlation coefficient of 0.37, that's a pretty moderate correlation. It's positive. And that, let me give you an example of that. Grades and intelligence. Okay, so are grades and intelligence related? The answer is yes. They do have a positive correlation, but it's not a perfect, strong positive. Okay, it's a weak positive, but it's definitely a positive correlation. Intelligent people tend to have better grades, but we all know a bunch of people who are really intelligent and they end up dropping out. We all know somebody like that. I usually have a student like that in every classroom. They're super intelligent and they end up dropping out. Okay, so grades and intelligence are positively correlated, but it's not a perfect positive correlation. It's not perfect. Okay. So whenever you see, think of it as a positive slope. Okay. On top here, you've got a perfect positive correlation, a slope of 1. If you're going to do a slope of that line, it would be a positive 1. If it's a straight line, then it's going to be 1. Same thing on bottom, you've got a negative correlation. That is a -1. That is a perfect negative correlation. Okay. Now, if you have no relationship, then you don't have a line. Then the correlation is 0. So these are called scatter plots, and you'll see more of these in a minute. But scatter plots are like what you get when you put the data up there, and it's rarely a perfect positive or a perfect negative. It's sometimes you'll see trends, and I'll show you what that is. Okay. So also remember this: strength simply means how far away from it is it from 0. So a point, like for example, the strongest correlation coefficient on here would be not D, because it has to be 1 or less, and it has to be greater than -1. It can be equal to -1. But anything outside of that, it's invalid. So it's not D. C and E are very weak because they're very close to 0. They're almost non-existent. C and E are very, very weak. B and A are both strong, but the strongest relationship on here is B, okay? Because it is the furthest away from 0. It doesn't matter if it's positive or negative. B would be a strong negative correlation. How about, here's an example of a negative correlation: weight and running speed. So the lighter I am, then the faster I can run. Now, we all know that that's not absolutely the most true thing, but again, it's not a perfect negative correlation. But if I lose 20 pounds, I'm going to be able to run faster. That's a negative correlation. Okay. So A would be a positive correlation. And C would be like no correlation. Like a correlation coefficient of 0 would be like the GDP of Zimbabwe and the caloric intake of Hawaiians. They have nothing to do with each other, so that would be a 0 correlation. Okay. So check this out, and this is actually a real question from the AP exam. Notice that it's not a straight line, it's a scatter plot. But you can see that if you were to take the average of this data, you would get a straight line like right in the middle to average it. Now, is this a positive correlation? Is it a negative correlation? Or is it no correlation at all? It is a positive correlation. So hit pause and, a research group conducted a study of investigating the connection between self-reported number of hours slept in a given week and scores on a happiness measure. So happiness and the number of hours of sleep are correlated. Now, it's not a perfect positive correlation, but to a large extent, the more sleep you get, the happier you are. So according to this chart, and the answer is B. Okay? The answer. No, it's B. I got the error wrong. It's B. Okay? All right. Researchers have found a negative correlation between income and dental problems. Okay, so think about that. Negative correlation. One goes up and the other goes down. That's a negative correlation. What conclusion can correctly be drawn from this statement? Hit pause. This is now remember this. We're talking about correlation. We're not talking about cause and effect. So rule out A. Okay, we're not talking about cause. We're just talking about these things are related. One goes up and the other goes down. Make sure it's also a true statement. As income, looking at B, as income increases, the likelihood of requiring dental care also increases. That is not that would be a positive correlation. So it's not B. Look at C. A rise in the incidence of dental problems causes income to be lower. That's a ridiculous statement anyway. And plus, we're not talking about cause and effect. So it's not C. The answer is D. As income increases, the likelihood of dental problems decreases. Okay? E looks good, but in order for it to be more affordable, you would have more dental problems. So that would be not what the original question asked. The answer is D. Okay, interesting question. Okay. A major disadvantage of the experimental method. Oh, okay. So we didn't talk about that this time, but experiments are not real life. Okay, there's a certain amount of artificiality attached to it. You know, being in a laboratory is not the real world. So that is a disadvantage of the experiment. Okay. Of the following correlation coefficients, the correlation coefficient that indicates the strongest relationship between the two variables being measured is what? Okay, so it's not D, it's not C. C is the weakest. The answer is B. The answer is B, because it's the furthest away from zero. And yes, it's a negative correlation, but it's a strong negative correlation. A correlation coefficient of 0 means that, and the answer is D, no relationship between two variables. Okay. Experimental research differs from correlational research in that experimental research cause and effect. Cause and effect. So once you do your study, then you need to analyze your results using statistics. You do need to know what mean, median, and mode is. Okay, you've learned that since the 8th grade. Mean is the average. Median, here's how you remember median. You're driving down the road and there's a median in the middle of the road. The mode is the most common number in a set. So if I were to take a survey of the age of everybody in my classroom, the mode would probably be 16 or 17. Okay. That would be the most common age in my classroom. Then you talk about variation. Okay. How close together are the numbers in a set? So make sure you know these three terms. Okay. Remember the median. If it's an odd number of numbers in a list, you take the middle one. Okay. If it's an even number, then you average the middle two, like right here. Oh, and to do a median, you have to list them from least to greatest. You got to do that to know what the middle is. The mode would be the most common value, and in this case, 9.6, because there are three of them. The mean is you take them all and you average them. Okay? Standard deviation. Okay, so to the annoyance of every statistics teacher out there, let me tell you what standard deviation is. It's how far apart the data are. Like, look. So look at my hand. This is low standard deviation. This is high standard deviation. Lower, higher. So standard deviation means that the numbers are spread apart. So let's take the standard deviation of my classroom. The standard deviation, you get 16-year-olds, 17-year-olds, 18-year-olds. You might get the occasional 19-year-old. You might get the occasional 15-year-old. So on average, the standard deviation is about 1 year. Think about the word deviate, change, okay? But let's say you go to a college classroom. You get a bunch of 18-year-olds, you get a bunch of 19-year-olds, 20-year-olds. You might get a 17-year-old, you might get a 30-year-old, you might get an 80-year-old. So the standard deviation in a college classroom is going to be greater than the standard deviation of a high school classroom. Okay? So what is the median of the following distribution? Hit pause, work it out. What is in the middle? And the answer is 5. So you list them in order, 2, 3, 4, 6, 7, 9. And you take 4 and 6, you average them together, and you get 5. Even though 5 isn't on there, the answer is 5. Standard deviation is a measure of how much. Okay, you're going to hate me, but the answer is D. So it's about differ from the average. Okay, so you got an average, and it's a matter of the distance between each datum has between that and the average. Okay? Okay? All right. All right. A test has a mean of 80 with a standard deviation of 4. Which of the following scores is within 1 standard deviation of the mean? Okay, you read that a couple of times, and then you'll see that this question is a little tricky, but just think of it. Mean is 80, and the standard deviation is 4. So which one of these answers is within 4 of 80? And the answer is B. The answer is B. Okay. All right. So this was actually on the AP exam, and I'm sorry I gave you the answer. I didn't mean to. Kara plays on the high school basketball team. Her scores for the season are presented in the table below. What is the range? The range is the biggest number, subtract the smallest number. So 19 minus 4, so that's 15 range. Okay? In my classroom, the range is typically 3 or 4. Okay, the oldest kid minus the age of the youngest kid, because we might get an occasional freshman in there. Okay, and occasionally we'll get a 19-year-old senior. Okay, what is the median? What is the median? Sorry, it's covered up. So you take the middle two, and you average them, and you get 9.5. The median of this thing right here is 9.5. The midpoint between the two middle numbers. Okay. Okay, this is interesting, and you need to know this. Statistical significance. It's the degree to which a result cannot be reasonably attributed to the operation of chance or random factors alone. In other words, is the difference meaningful or is it just random? Okay, that definition isn't going to help you, so let me explain. Let's say you do an experiment, okay? And you want to know if eating bananas is going to cause you to lose weight. So you eat a banana every day for a week. And then at the end of a week, you lose a pound. So is 1 pound enough to conclude that bananas cause you to lose weight? Or is that 1 pound just part of the normal ups and downs of your body weight? Okay. Is your experiment, that 1 pound loss, statistically significant? Okay. Here's another example. And this is now I made up the numbers, but this actually happened last year. I looked at students who did their quizzes, and then I looked at their test scores, their actual paper test scores. And I wanted to know what the correlation was, not causation. I didn't do an experiment, but let's look at the correlation. I took the students who did their quizzes and I looked at their test score. And my students got a 68.5 on average, what they made on their test. And then I took the kids who didn't do their quizzes and I averaged their test scores, and they got a 64.75. Now, I might have made up these numbers, but it's similar to what the reality was. But then again, I may have used real numbers. So, and I started to ask myself, is quizzes even worthwhile? Because if the kids that do the quizzes are only scoring just a little tiny bit more than the kids who aren't doing the quizzes, I started asking myself, is this worthwhile? Is this meaningful? Does quizzes lead to a meaningful increase of performance on tests? And the answer is I'm not absolutely sure. Okay, is 4.25 point difference here, is that meaningful, or is that due to just random variations? Is this result statistically significant, or is it just due to random chance? Okay, maybe the people in the quizzes group just felt better that on that one day that we took a test, and then in the non-quizzes group, they weren't feeling so good for some reason. So if I really want to know, does quizzes do any good, I need to do an experiment, and I need to randomly assign students to take the quizzes and some students to not take the quizzes. And then I need to give them both the same test to see how they do on the test. That would be an experiment. Now, that would be unethical because I don't want to mess with students' grades. Okay. So is this difference meaningful, or is it just random chance? Is this statistically significant? All right. An instructor did an experiment to determine the effects of two different methods of study on the amount students learned in introductory physics. The results showed that the average amount learned by the group using one method was greater than the average amount learned by the group using the other. However, the difference was not statistically significant. Which is the most appropriate conclusion? Hit pause. The answer is E. Okay? If you tried one method of study and then you tried another method of study, and then one group did only slightly better than the other, then the answer is E. The group, it was not statistically significant, and that the difference was just due to just random chance. Okay? Like studying people who study with music versus people who don't study with music. And then one group scored just a little bit higher than the other. Maybe that's just due to normal random variations. The answer is E. Let's talk a little bit about bias. Remember, when you look at a study, you need to know who is doing the study. If you run into a study that says milk reduces osteoporosis or milk causes you to lose weight, then you need to think about who paid for that study. If the American Dairy Association funded that study, then that is a biased study. Okay? Okay, sorry for giving you the answer here, but in experimental psychology, a significant difference refers to a difference not likely due to chance, meaning that the independent variable did cause the dependent variable and not just random chance. All right, now let's talk about ethics. When you do a psychological study, you have to follow ethics. What happens is that there's something called an institutional review board. It's called an IRB for short. Every university has one. And what they do is when you want to do real research, you have to go to these guys and they have to look at your what you're going to do, and they have to critique it, and then they have to make sure that you are not only doing proper methodological methods, you're doing it right, also that you are being ethical. Okay, so let's talk about ethics. With animals, there are guidelines for ethical animal research. You can't just go and throw acid in kittens' eyes for fun. Okay, it must have a clear scientific purpose. And the animals must be cared for humanely. The animals must be trapped or bought legally. You can't just go kidnap a monkey in the middle of the jungle and bring them back. You can't do that. And suffering must be minimized. Okay, so if there is suffering, you better have a good reason for it, and it better be minimized. Now, for human research, this is important. This shows up on every test, every AP exam, this shows up. And some of this is going to sound strange because I teach so many examples of how these guidelines are violated. Coercion. You cannot force people to be a part of your study. It must be voluntary. Okay? Informed consent. Consent means permission. They must know that they are involved in research and give their consent, their permission. If they are deceived, what they did consent to must be similar to the actual study. And you must minimize trauma. Okay, so you can't just do twin research and separate twins at birth and raise them with different parents to see how that affects them. You can't do that. That is a violation of guidelines for human research. And you can't mess with babies. Remember the Little Albert experiment by John Watson? That was traumatic. Okay, I mean, I don't want to be over dramatic, but you can't scare babies for fun. Okay. When you do studies, you must respect people's privacy. It must be anonymous. So let's say you were doing a study on sexual desire or homosexuality, and then you publish people's names in a local newspaper. You can't do that. You can't do that. You can't call people out like that in public. People, it must be anonymous, okay? Unless they agree to it otherwise. Risk. You must not risk people's mental and physical safety. Hopefully, you learn about the Zimbardo's prison experiment, okay, and how that was a violation of this. And then debriefing. After the experiment is over, participants must be told of the purpose of the study. And the people need to be able to contact the researcher to discuss the results. So um, if you are a part of an experiment or some sort of psychological research, you need to have a number or some sort of contact that you can call to discuss the results. That is one of the ethical guidelines for human research. Okay. Another violation of this you could think of Stanley Milgram's shock experiment. Okay, and that's in social psychology. Okay. All right. So check this out. A psychological researcher designs a study to determine whether positive feedback. Actually, no, we'll do this separately. Y'all have a good day, okay? So, actually, all right, that's it for today. Thanks a lot.